Hey guys, welcome to the video series on data engineering on Microsoft Azure DP 203. Hope you guys are doing well and staying safe. In today's video, we will try to understand the Azure Cosmos DB storage. This picture best describes the Azure Cosmos DB. It is a fully managed database service with turnkey global distribution and transparent multi-master application. It has single-digit latency and high throughput, so it's best fit for the applications which are highly responsive and always available, such as web, mobile, or gaming, etc. And to ingest data into Azure Cosmos DB, it can be done through the application and other APIs, etc. And in this picture, you can see like data is replicated globally across is replicated globally. So this can be easily achieved by just a turnkey feature, which we will see in the demo. Like it's very easy. You just click on something and it will replicate there. And Azure Cosmos DB supports multiple APIs. They are highlighted at the top: SQL, MongoDB, Gremlin, Cassandra, Table. And these APIs are used for different types of NoSQL databases. These are key value. So key value is used by Table, column family is used by Cassandra, documents used by SQL and MongoDB, and graph is for Grammarly. And these are the some other features of Azure Cosmos DB, like guaranteed speed, which we guaranteed speed at any scale, which we already talk about, like single digit latency and high throughput. Simplified application development, it integrates well with the other applications. Mission critical ready. The turnkey or like replication factors make it mission critical ready in any situation, and fully managed and cost effective. So this is the structure of Azure Cosmos DB account. So we'll start from the left. So when you create an Azure Cosmos DB account, it will have a database account, which will be the top hierarchy. Then it will have multiple databases, and multiple databases will have container objects, and in containers you will have various other objects like store procedure, user defined triggers, and all those kind of things. And containers, depending on which API you're using, container will be categorized accordingly. So if we are using, let's say, SQL and MongoDB, it will be collection. So it will be collection. If we're using table, it will be the table. If you're using graph, and so on. And same thing goes with the items too. If it's depending on your Cosmos API, the item will be realized as a document, row, node, and edge. So document will be for SQL and MongoDB, row for the tables, node for the columnars, and edge for the graph. So next thing is like I want to talk about is partitioning. So before we start, there will going to be a separate video on partitioning for all Azure data storage services, including Cosmos DB. But we need this to create containers in Azure Cosmos DB. That's why we are discussing here. So as I mentioned, like we need this while creating a container, so it's critical. So let's try to understand how partitioning works in Azure Cosmos DB. The partitioning basically is the items in the container are logically divided. Items in the container are divided into distinct subsets. We call them logical partitions. And once data, so you can see there, like in your data, let's say in your database, you have two containers. One container is partitioned using partition key city. Other one is used by airport. So for each city, the data is this. These are called logical partitions, and same goes for the airport. These are called logical partitions. But once like logical partitioning is done, the items are, once logical partitioning is done, it's the Cosmos DB data engine, database engine that divides to which physical partition they will land. So as a user, we just care of the partition key, but the Azure Cosmos DB engine will take care of this. So from this diagram, we can see London, New York, Paris will fall into this physical partition. Rome goes here, and the airport AMS goes into this partition, and LAX and C goes into this physical partition. So one physical partition can have multiple logical partitions in it. Next is the shared and dedicated throughput. So I'll show in the demo. There it will be easy to understand and easy to grab. So let's jump into the demo, and we'll come back here to this PowerPoint to cover our last slide, which is like showing the I'll say the like trade-offs of different consistencies, and I'll explain that in demo only. So let's go. So I've already created a database account in Cosmos DB, but I'll show you, because it takes like approximately 10 minutes to create an account. So I'll show you how simple it is. Click on create button, search for Azure Cosmos DB, and click on the create button, and based on what type of data you're going to handle, you can pick whatever data API for that. So you have to pick the API according to your database you're going to use. So click on, let's say we want to start with SQL, click on create. Then we have to pick the resource group, give the name. So let's give it test. Oh, it needs to be data tech test 2, or like Cosmos DB 2. Then pick the reason, whatever based on your location. So I'm in East ES2, and after that, like you go here. This is the global distribution which I was talking about. So hey, like you can enable these global distribution features from here, or even if we don't, like we can also change these settings later in the account, which I want to show you guys, and that is also known as turnkey global distribution. And this is like this is critical from high availability and disaster recovery, as you guys are remember from Azure Data Lake Gen 2. There we have like 4 options, but here it's like it give you more graphical way. Like you can do it from here too, but like I'll show you in the account like how they you can do it from the graphical way. Rest of the things you can leave it as it is, and click on review, and click here. It will validate, and it will show you how much time like it will need. So it says 10 minutes. If you click on this, like in 10 minutes it will be created. I've already created, so I'll go back to my created account. Okay, so you can click on the Data Explorer. I want to show you so this is our database account. Now we have to create a new container, so we click on this. So it says like if you remember the structure, if you go back to the slide, the first thing is the database account, which we already created. This is the database account name, and the next thing will be the database and the containers. I've already created a database named OLTP, but you want to create a new one, you can create a new one too. And then container ID, what container you want, partition key, and all those kind of things. But let's create a new container. Sorry, let's go here and create a new container. Click on Data Explorer, new container. I'll give it OLAP name. And the other thing which I mentioned, like I will show you through shared throughput, across shared and dedicated throughput. So if you see here, like when I'm creating a new database, and this option is by default, so whatever throughput this database will have will be shared by all the containers within it. And a database can have multiple containers, So let's say if it has 1,000 throughput and it have 5 containers in it, all these containers will have 200 throughput to it. So if we don't want to share it, we just want to create a dedicated throughput to our container, just uncheck it, give it a container name. Let's give it a families. Sorry, let's correct the spelling. Partition key, which I mentioned. This is the logical partition key which we are doing, but like in our future videos we'll see like what things we need to consider even while creating a like a logical partition key. But like this is a logical partition key, and then Azure Cosmos DB engine will create a physical partition key. And here we can this is a dedicated container throughput. If you click on manual, you can give whatever number you want, and if you want, like if you don't want manual, you want to share it at the database level, you can click it here. So depending on like your requirement or what kind depending on your requirement, you can share the throughput across all the containers, or you can give it to the dedicated. I'll click it share, and then you can click OK. It take a couple of it's fast, it won't take that long, and once this step is done, you will see another container with the name OLAP. Sorry, not container, like another database with name OLAP. Let me close this, go here, Explorer. See, so we have, this is a database account, these are databases. So a database account can have multiple databases, OLP, OLTP. And if you expand this, you will see families. This is a container. And if you expand this, so I've already created one, but this is a container. You go here and items, like it's a SQL, like you can query the data in these items using this SQL, but at this moment there is nothing. Let's load it. So if we go back in Explorer, look at this. So you see there are like 2 records are, well, let me make it more visible. So these are the 2 records, which two documents which we uploaded here, and you can query this like from this too. You can copy, paste, Control C, and close this. Item, not a new, like you can copy as a new notebook. You can write it, 1 second. Yeah, here. My bad, sorry. No, let me close this. So you can query it as a SQL too. Just give me 1 second. Go to Data Explorer, OLAP, families, item, and yeah, you click on this, and then if you run this, you will see the document, you will see the content of the document. Perfect. So now we have covered the shared throughput and others. Now let's look at the like a turnkey feature here. So if I click on this replicated data global thing, so this was the thing I was telling at that point, like you can like do a global distribution just with a single click. They make it that simple. So if I click on, let's say I'm in East US, but if I want to replicate it to anywhere in this world, like I can simply go there and click on that. Like if I want to go to Japan West, I can click on this. If I want to go to Australia, I can India, Africa, Brazil, wherever I want. Like I can just with a single click, I can do that. But so that's like one thing which which make our life easy. Like with a single turnkey, things are available. That's one thing. Second is like we need to keep in mind like our main reason is like the read reason, and the other reasons which are we clicking are read reasons at this point, because we haven't enabled our read write. So if you click on enable, like I'm just like not going to do that because it takes times, but if you enable, they both become read write. You can see it here. So both become read and write, and in that scenario, if any disaster happens, Azure automatically, let's say if East US goes down, it automatically copy our storage will from center US will start from center US will start working automatically. Okay, that's one thing we need to keep. So if it's like a read option when we are globally replicating, you don't have to worry about anything. But if let's say if it's not read option, it's something like this, you just have only one write reason and others are the read reason. In that case, you, if any failure happens, like you have to take care, like you have to use either automatic failover or manual failover. So in manual failover, like I know I have only two reasons, but let's say if I have East US, Central US, and West US, and they both are read, so I can select one and make it as soon as trigger happen or anything goes wrong, it will become my write reason. And if I go back here and in automatic, like I simply turn it on, in that case, like Azure will make the decision on based on Azure will make a decision like, okay, if one reason goes down, which other read reason need to be enabled for Cosmos DB. And then the last topic I want to talk about is the consistency. So consistency is you will be wondering what is consistency here. So here consistency is like a uniformity of the data in the distributed database. So because we are replicating the data between different data centers through that turnkey options, but these data centers these are separated hundreds or thousands miles away from each other. So in that case, the consistency could not be same if somebody is writing at the same time and other person want to read it. So for that, there are like 5 consistency options are available. So we'll start with the strong. So strong consistency is the strictest model where data written using this consistency is synchronously replicated in every data centers. It's supposed to, like, in every replica basically. And the second one is the bound stainless. In this, like, data is replicated asynchronously based on a predetermined window or I'll say number of writes. So what happened in this one, like it is you can so in this one, like anything comes under the window will be strongly, it will be like have the same consistency, but anything, so that's this session is a unique or by default consistency, which is basically client centric, not the data centric, in which like a person in the same session will have the consistency while the person in another session won't have the consistency. Consistency prefix is basically if a write was performed in an order ABC, then client see either AB or ABC, but it will never be something in the AC or BAC or in some like I'll say like it has to be in an order. It can't be unordered. And the last one, the eventually, which is like the weakest, and in this one, like consistency will not be there. Like you might read something which is not written, like things won't be in an order, and this is the weakest consistency. So the trade-off all these things is, if you want so these are the trade-off of Azure Cosmos DB consistency. If you want a strong consistent, like anything here, there will be strong consistency, but it will have a high latency, lower throughput, while this will have weaker consistency but lower latency and higher throughput. So depending on your requirements, because this is for the replica or the places where we replicating our copy, it's for that. So depending on your requirements, you can go whatever consistency fits well with your requirements. Thank you. That's all for this video. Stay tuned for our next video. Have a good one.